LeetCode Problem 25, Reverse Nodes in K group. So this problem gives us a linked list, and our goal is to reverse the nodes of the list K at the time, and then return the modified list. So what this means is that, let's say if K were to be 2, so here we have a 1, 2, 3, 4, 5. So in groups of 2, so this is one group, this is one group, and this is one group, right? So we have to reverse this. So this will be 2, 1, reverse this 4, 3, and then since this does not have a group, we do not need to do anything else, right? So we 5. So we cannot alter the values in the list nodes, and only the nodes themselves may be changed, right? So we can only move the nodes around. We cannot change the nodes value. Okay. So my approach to this is to use a recursion, right? So this recursion is basically for iterating through each group. Okay, so I explain step by step of how my code works. So first we have the head. So I'm going to use the example they gave for 5. Okay, this, right? And the K is 2. Let me put it here instead. Alright, so what you see here, this is basically this int 0, and then you have this is basically used to check whether or not the current group have enough node to form a group. Like, so if let's say current were to reach null, like for this instance this group were to reach null, then the count will be lesser than k, right? And when it happens, we return a head. Okay, I'll explain why we return a head later, but just know that this is basically used to count whether or not we have a group or not. Right? So technically we can ignore this first. Okay, I have a variable here called current. The current is pointed to our head. This is what we'll be using to iterating through the list without changing the pointer of the head. Right. So I set current to head here, and then here is where I reverse the list. Right. Okay. So I have a previous here. So I'm just gonna do like this. Previous, next, then current. Right, so current technically is this is 1 now, right? Current technically is 1. This basically is just a normal linked list reversal. So I'll just go through it briefly. So what it first do is the next will be current next. So next here will be current next with a 2, and then the current next will actually be the previous, right? So the current next, so this 1 will now actually be pointing not at 2 but at null, right? Because our previous is null. So if you were to put like this, also can, right? Where 1 is pointing null, and this is how you actually reverse it. So here you have 2, like this. Okay, let's not jump ahead first. So current next equals to previous. Previous is equals to current. So previous equals to current. So our current now is 1. So 1, and then current is now next. So current is now next, which is 2. So here. Okay. And then well, our I will plus once, since I is still less than 2, we have one more reversal to do. So we reverse again. Right. So next equals to current next, which is 3. Right, next equals current next 3. Current next is 2 should now be pointing at our previous. So this 2 will now be pointing at 1 because our previous was 1. So we have this. And then remove the link here. And then previous equals to current. Current equals to next. 3. Okay. After that, this for loop ends. Right, so you can see that we have reversed our link. We have reversed our list here. And then what we're actually going to do is I'll hit next. Right? So I'm going to reverse this list one more time. Now, should be like this, right? So this is the head, right? Our head is actually defined here. This is not the head, sorry, this is just the list. Our head is actually 1 from here. Our head is 1. Our head never changed actually. So, write it again. Let's increase. It's 1, right? Our head is 1. It's basically a list. Okay, but we will use the node 1. We bring the list down. Okay, so this one, which is now pointing at null, will be replaced with a recursion. So for recursion, I'm just going to do this, and then we do everything again, right? So now our head is actually going to be next, right? So our next is 3, and the k still says same as 2, right? So here you kind of see that everything is the same, right? Everything is the same. So we can just ignore this for now. Current goes ahead. Okay, and then we do the reversal again. So next goes to current next. So next goes to current next, which is 4. Current next, which is 3. We'll now need to point the list. So this 3 will now need to point at our previous, which is null over here, right? 3 pointing at null, like this, and then loop again. So now this 4 will point at 4, right? Because previous equals to current, 3 current equals to next. Okay, then next equals to current next is 5. Current next equals to previous, which we're already linked. So this is, we delete this. Previous equals to current, and then current equals to next. Here's 5. Okay, so now link looks like this. I'll rewrite it. So it is 4, 3, and now then we will recurse again. Okay, with the head being 5. Okay, so here you can see if so now we focus on here. So I have a variable called count is 0, iterating through the list, and while the head is not null, I'll increment the count, right? But in this case, we can only increment it one time, so count is 1, and 1 is less than k, right? Lk is 2. So we do not need to do anything, we can just return this head, right? Return the head, which is 5. So our linked list, so this head next equals to 5 over here. Okay, after that we return the previous, which is the first node, technically is the head of our reversed linked list. So return the head, and this return back to here. So this is what our modified list look like. You can see it's the same as the answer, 2, 1, 4, 3, 5. And then when we return previous again, which is 2, basically returning the head of the modified list. Okay, this problem is it's a bit challenging, but at the end, by using recursion, it is technically just iterating through the list and doing the same process over and over again. Okay, that's all I have to show. Thanks.